This is our second example on exact equation. Okay, in this second video, what we want to discuss is about how to solve the exact equation. So let's say we are given this kind of equation. Solve the following differential equation. So this is the equation. Okay. Y just now, right? Solve the following differential equation given that y equals to 3 when x 0. So this question requires us to find the particular solution. So first of all, we try to avoid this one first. Okay, so we just focus on how to solve for the differential equation. Okay, since this equation is already in the form of m dx plus n, okay, plus n dy equals to 0. Okay, so I will try to say that this one is an exact equation. So in order to say that this equation is exact, so what we need to do is we need to show the we must do the exactness test. Okay, we test for the exactness so that we have del m del y, okay, is it equals to del n del x. Del m del y, so this is our m, so differentiate m with respect to y will give us 3x squared. Differentiate our n with respect to x will give us 3x squared also. When we differentiate partially our function with respect to x, other than variable x, we must treat as a constant. So differentiate constant will give us 0. The same thing to this one. When we differentiate partially with respect to y, means that other than variable y, we must treat it as a constant. Differentiate constant will give us 0. So we can apply a product rule here. Okay, so this one is just direct differentiation. Okay, so now since we know that del m del y equals to del n del x, therefore this equation is exact. Okay, since the exactness test is fulfilled, therefore we can say that there must exist a solution. Okay, there must be a solution where the solution is a continuous function in the form of fxy equals to a constant, any constant. So highlight this one as our solution. In order to get this solution, okay, so we must set up the first and the second equation. The first equation regarding to your m. So we have del f, okay, del x equals to our m. What is our m? M is 3x squared y minus 1. Okay, and then the second one is del f del y, which is your n. What is our n? So we have x cubed plus 6y minus y squared. So we just equate this equation as equation 1 and equation 2. Okay, so now we want to solve. Okay, we know that the solution is f, but we are given both of equation 1 and equation 2 in the form of derivative. So in order to get only f, so what we need to do is choose either equation 1 or equation 2. You need to integrate the equation with respect to either x or y. So let's say I want to solve for equation 1. Okay, so what I need to do is integrate both sides of the equation with respect to x. Okay, so integrate something that you differentiate here so that we just have only f on our left, but our right, so that we have integrate with respect to x so that we have 3x cubed over 3, right? So we have x cubed, okay, y minus integrate 1 with respect to x will give us x. And do not forget to plus an arbitrary function as a function of y. So let's say this is equation 3. Okay, so since our right hand side of our equation consists of x and y variables, so our f here is as a function of x and y. So class, actually this is the solution that we wish to find. fxy equals to anything that you have on your right, okay? But we need to find out what is our phi y. Okay, so now the step is, in order to find phi y, what we need to do is we need to differentiate. Okay, differentiate equation 3 with respect to y. What do you have here is differentiate your left hand side will give you del f del y. Your right hand side differentiate with respect to y will give you x cube minus differentiate constant will give you 0, and then differentiate this one will give you plus the first derivative of phi y. Let's say this one is equation 4. Okay, so now as I mentioned earlier, we just want to find what is phi y, but you have phi prime y. Yes, we can find phi y from phi prime y. So what we need to do is we need to compare equation 4 with the equation that we didn't use just now, okay, which is equation 2. So when we try to compare, the left hand side we have the same term, so that I just cancel out. Okay, what happened to your right? So x cube also we can cancel out. So what's left? So we have phi prime y equals to 6y minus y square. I can say that this one is equation 5. Okay, again class, we don't want phi prime y, we want phi y. So what we can do is we can integrate both sides of this equation with respect to y. Integrate something that you have derivative or differentiation here will give you only phi y. While your right hand side you will have 6y square over 2, so you have 3y square minus y cube over 3. Then only here you can plus a constant, let's say b. Okay, so this is equation 6. So now I already find the unknown or the arbitrary function of phi y, so that I just substitute what I have in equation 6 into equation 3, where I will have fxy equals to x cubed y minus x. So phi here is plus 3y square minus y cubed over 3 plus b. So let's say this is our solution, but we are not finished yet, because we know that but fxy must be a constant c. Okay, so that I replace this one as c, so I have c equals to x cubed y minus x plus 3y square minus y cubed over 3 plus b. Since we have two constants which are b and c, so that I have only a, which is x cubed y minus x plus 3y square minus y cubed over 3, where a equals to c minus b. So this is our general solution. Do not forget that the question gives you the initial condition, y equals to 3 when x equals to 0. So now y equals to 3, okay, I put this one as initial condition, y equals to 3 when x equals to 0, and then I substitute into our general solution what we have. A equals to, so 0, so this one is 0, so this one is 3, 9, okay, this one 3, 9, minus 27 over 3, which is 9, okay, done. So that we can say that A equals to 27 minus 9, which is 18. Okay, so A equals to 18. So we can conclude that the particular solution is x squared y minus x plus 3y squared minus 1 over 3y cubed equals to 18. So this is your fxy, and then this is the constant. So this is how you can find the solution of exact equation. Thank you.